Hey everybody, in this video we are going to solve the inequality that you see on your screen right now. It's quite similar to the last example, except one main difference is that instead of it being less than 0, it's asking about this being greater than or equal to 0. So not only do we have a greater than, but we also have an or equals situation. These are pretty simple types of examples because they're already equal to 0 and they don't involve any type of asymptotes. So let's get into this. If you need more deeper analysis, at the end of the video there will be a thumbnail to my inequalities playlist. There is a full thorough breakdown of a bunch of examples there, so you can go there for more support. So here what we're going to do is we want to know, first of all, we recognize it's a parabola, and we want to know when is this parabola greater than or equal to 0, where 0 is represented by the, that's not at all the way I want it to look, represented by the x-axis. It will be greater when it's above, so that's going to be from here until there, equal to, greater here. We describe the x values. Think of it like a timeline. Like, oh, when was this person, when was so-and-so, president or whatever. Oh, they were president from here to here, and then they took a break, and then they were president again from here to here, whatever. Something like, like that. Okay, so how do you get x-intercepts? You need those to figure out where it crosses the x-axis, and we get those by getting your polynomial to 0 and then factoring. 2x squared, 2 is prime, only even prime number. So it's got to be 2x and x for my first terms. Now 4. 4 could either be a 2 and a 2, which it won't be because then I have a GCF of 2 here, which means I need a GCF of 2 here. I don't have that, so that's out. Or I could have 4, 1, which again, that's out for the exact same reason. Or I could have 1, 4. So really, that's the only thing that works. So let's check it out. Outer is 8x. 1x, if they're both positive, I get 9x, and that sounds good to me, right? First is 2x squared, check. Last times last is plus 4, check. So I'm factored. Now, getting my x-intercepts, I set each factor, zero product property style, set each factor equal to 0, and I get x equals negative 1/2, and x plus 4 is 0, so x equals, obviously you don't have to show all these steps, x is negative 4. Those are representative of my x-intercepts. I'm going to go over here. I'm going to do it more number liney, but negative 1/2 is an x-intercept. Oh, that would be, I thought it was positive 4. So negative 4 would be to the left, and negative 1/2 would be to the right because, the order of numbers. These are colored in because we said or equal to, and I know what it looks like because it's a parabola with a positive leading term. The positive leading term indicates that the right side finishes pointing up, and then the fact that each of these parentheses that these factors came from, here first power and first power, which means they behave like a first power equation or a linear, and they cut right through. If it was second power, it would touch and bounce off. It would be quadratic behavior and so on. Now, my final answer is asking the question, or to get my final answer, they're asking the question, when is this graph greater than or equal to 0? Sometimes I tell my students to fold their paper, and cover the whole bottom and be like, what is this describing? Obviously, I just erased the numbers, but basically, you're trying to answer, what is this, using x. So my answer, in interval notation, I think that this is better than a number line. So if you were to do this for me and it was your number line, right, and you showed me that that's what's shaded, that's fine. Interval notation will be, can I fit it next to SpongeBob? No, I'm going to have to put it under. From left to right, negative infinity, comma, negative 4 with a bracket, union, bracket, negative 1/2, comma, positive infinity. And that is the final answer. If you are insistent upon doing this number line style, it's the exact same thing. Negative 4, negative 1/2, except you would just color it in that way. All right, so this way of doing it with the graph is really more unique of a method. It's not really in textbooks this way most of the time, but I think it might introduce it this way and they don't have to ask you to solve it this way, but I think it's so much more efficient and it will help you in calculus a ton. Okay, I taught calc for many, many years. Just trust the process. So there you go. That's your final answer. If you need help, go to that playlist I recommended. It's on the screen probably right now, or ask me a question. But if you feel like, oh, I finally got this, go ahead, thumbs up. If not, thumbs down. And that's it for now. Adios.